Let's move on to another important concept of contingency tables. Using a contingency table is an easy and effective way to ascertain probabilities when the data is in the form of discrete frequencies. Let's understand this with the help of an example. Let's say we are talking about an engineering college where we get students who study electronics, mechanical, and computer science. And let's say that this college has different companies visiting for placements. So there is a company A, company B, and a company C. This table represents how many people historically have been selected, say, by company A from electronics, mechanical, and computer science. So company A has selected total 68 people, and this is how the frequencies are distributed. 22 students from electronics, 28 students from mechanical, and 18 students from computer science, and so on and so forth for company B and C. And then we have these totals of rows and columns. So total of 229 students who've been selected in different companies who belong to these three traits where they've studied. Let's see how do we use contingency table to solve problems. So suppose if somebody was to ask you probability that a student chosen at random is a student of computer science. Now you know that computer science students in total are 69, and the total students that we have are 229. So the probability here would be nothing but 69 over 229, which is the outcomes of interest divided by the total possibilities. Let's say if we were asked probability that a student of mechanical engineering qualifies for company A. Now if you see, this is nothing but an intersection type of a problem. Where do we have mechanical engineering? Well, we have total 85 students of mechanical engineering. But how many of them have qualified for company A? There are only 28 students. So we will say here that the probability is 28 over 229. Let's try to solve some more problems to get further clarity. So now let's say there's another problem. Somebody's asking us, what is the probability that a student of electronics gets placed in company B or company C? So we know that this is the column of our interest because this is where we are talking about the students of electronics. And we see that 34 students got placed in company B and 19 students got placed in company C. We are assuming that people are not getting placed in two companies at the same time. So how do we calculate the probability here? Well, it's simple. 34 over 229 for getting placed in company B and 19 over 229 for getting placed in company C. And the total would be 53 over 229, which you can calculate. One last question here. Probability that a student selected at random belongs to mechanical engineering or has qualified for company A. So now we're talking about either he belongs to mechanical engineering, which is this column and this is the total number, or he has qualified for company A. See, we need to understand that we are not talking about both the events occurring at the same time, but this is that one case where we see a slight overlap or an intersection. So how do we calculate it? It is 85 over 229, which is the probability of a student who belongs to the mechanical engineering trait. And total 68 students got placed in company A. So that's probability of the event B, which is 68 over 229. What do we need to subtract from that? We need to subtract the common portion which has appeared in both mechanical engineering and company A, and this would have appeared twice. So this is a typical union problem where you see a slight overlap between the two events. So what do? We just simply subtract 28 over 229, and this number comes out to be 125 over 229, which can be computed.